In this video, we're going to factor polynomials, but focus on trinomials. And there's two different ways that you can factor trinomials. There's the trial and error technique is one of them, and that's what we'll talk about in this video. And then in another video, I'll talk about using grouping to factor trinomials as well. So here we're going to focus on trial and error method. Now remember, your trinomials have three terms. So they're going to look something like this. Again, I'm using x for my variable, but it could be a y or a z or something different. So you have ax squared plus bx plus c. So what you do here is you're basically going to factor your first term and your last term to find combinations that give you a when you multiply and c when you multiply. So that's what this is saying here, is we're going to look for factors whose product is a and factors whose product is c. Now it's not just that simple. So what happens is your final answer looks something like this. So you have one group times another group is typically how it's set up. And when you multiply that all out, you need to also make sure that the middle term matches your original. So when you multiply out using that distributive property or using that FOIL technique, then that outside and inside combination, when you add them, has to be bx. So if you tend to be a person who's really good with your multiplication tables, then this is a technique that you could perform probably pretty quickly. But it is trial and error. It is true trial and error where you have to kind of think about the combinations that a and c could be for their factors and which ones are going to work so that when you multiply it out to check, you get your original answer. And let me show you, I'm going to start with a simple example here. So I have a trinomial, meaning I have three terms. And the first thing you're still going to check is always, is there an overall GCF? Now here I have a 1, 6, and 8. So nothing really in common there besides 1. And then they don't all have x's. So my overall GCF is just 1. So I can skip that first step of factoring out the GCF because 1 isn't going to change anything. So what we're going to do now is the process above. And I'm going to just kind of show you what it looks like when we're actually doing the work. So the first step here is to look at all possible factors for your first term. So if you think about x squared, the only way to get x squared is just x times x. So that one's pretty nice where it has to factor that way. And then what you do is you break down your last term and think about the possible factors. I like to write everything down. It just helps me to see all my possible values. This is a positive 8. So what two numbers could I multiply to get positive 8? I could do 1 times 8, or I could do -1 times -8. I could do 2 times 4, or I could do -2 times -4, right? All of those combinations would give me 8. And what I do now is I set up my two parentheses and I plug in my factors and play around until I find the right combination that would give me a 6 when I multiply it out. So the first part goes in the first set and the other part goes in the other set. So for instance, this one's kind of nice because I only have one choice here. So I know it has to be x and x, but I have 4 choices here for my other two values. So you can just go right in order if you want to and try them, or you could think a little bit ahead of time. I'll just do the first one just so you can see. So let's say I want to try 1 and 8. It's +1, +8. And then what you do is you multiply this out to see if it matches. So x times x is x squared. X times 8 is 8x. Here, 1 times x is 1x, and 1 times 8 is 8. So if I look at that inside and outside combination and I add them together, notice I get a 9x. My original problem had a 6 in it, so this doesn't match. Which means it's not the right combination. Okay. So this one here doesn't match. It's not the right combo. So what you're going to do, you're going to try again. So let's try again. I'm just going to do it right over here. Okay, so this was first attempt. And this is going to be second attempt. Now, if you're good at your multiplication tables, then you can hopefully think through some of these factors in your head first. So I know 1 and 8 didn't work. I'm going to skip over -1 and -8. If I try that one, I'm going to get the same result here, but I'm going to get a -9 in the middle. So I'm thinking maybe the 2 and the 4, and it's kind of jumping out at me because I'm thinking 2 and 4, 2 plus 4 is 6. This looks like it's going to work. So let's try that one. If I multiply it out, I get that x squared. Here I get the 4x. On the inside two parts, I get the 2x. And then here I get the +8. So if I look at that inside and outside term, 4 plus 2 is 6, and this one is correct. So because it matches the original value, my solution then is x plus 2, x plus 4. Now, a question you may be having is, well, what if you wrote x plus 4 and then x plus 2? That's totally fine as well. We have that multiplication is commutative, so you actually can switch the order of the factors as long as it's the full factor, right? We're not switching the numbers on the inside. We're just kind of rearranging those two groups, and that's fine. You're going to get the same result. All right, let's do some more. And I'm going to do quite a few examples in this video because it really does take some practice. So I want you to see a few different ones. All right, so let's do this one. We're going to factor. X squared minus 5x minus 14. So again, here, the first thing I'm going to look to see if there's an overall GCF. And if there's not, then I can just keep going. So here, my overall GCF, I shouldn't say it's not, it's just 1. So we don't really do anything with it. So it's just 1 here. There's nothing really in common. So I'm going to jump right in. So I look at my first group and I think about what are my possible factors. X squared is just x times x. Then I look at my next piece and I see a -14. So to get -14, I could do -1 times +14, +1 times -14, -2 times 7, or 2 times -7. And that looks like all my factors there. So we're going to set it up. Now, the first part's easy in this problem because I just have one option. So I know it's going to be x and x. But this part gets a little trickier because I need to get a -5 in the middle. Now, when the first part is x and x, it's pretty simple because you can kind of see the right factorization here. If I see a 5, I'm probably thinking 2s and 7s are going to work better. And I would be correct. So I'm just going to try the first one. I'm going to do, so this is going to be my first attempt. So I'll just do this first one here, -2, +7 is what I want to try. And then to check it, I'm going to multiply it out. And really what you need is those inner and outer terms. So this one here, so the 7x. On the inside, it becomes -2x when I multiply, and then here's -14. So if I look at this combination here, I get a +5x. Not quite there. We're so close. It's a -5, right? So I'm going to do it again. So this one didn't work. And I'm going to try again. Now, if you're only off by a negative, then likely you just pick the wrong pair. So we're going to do +2 and -7 instead. And what's going to happen if you multiply this out, you're going to see that you do get that -7x plus 2x and -14. So you're going to get that -5x in the middle. So our final result here is x plus 2, x minus 7. Okay. And again, you could also write it as x minus 7 and then x plus 2. That's fine as well. Okay. Now, let's make it a little bit harder. When the first term is just x and x for your options, it's pretty easy. Maybe not easy is the right word, but you have less options, so it's a little simpler. Here I have 8x squared minus 10x minus 3. So it's a little bit harder now because I don't just have an x squared there. I actually have a number, so I'm going to have more options to choose from. I usually like to make sure my initial term is positive. I think it's easier, but if the other terms are negative, it's fine. I'm not going to factor out a -1 for my GCF here. I tend to only do that if my leading term is negative. I just think it's easier to start with a positive term. So I'm going to do the same process. I'm going to factor this and factor this. So for 8x squared, I could have x times 8x, or I could have negative x times negative 8x. I could have 2x times 4x, or negative 2x times negative 4x. So I'm going to be honest, for my leading term, I like to keep it positive. I just think it's easier. So I'm actually not going to work with these. I'm going to choose to work with positive here. And then for my last term, as long as I have the signs correct, it'll still all work out. So just a little tip is for your first term, I like to keep that positive. And then my last term, I'll bring the sign in there, and then it will end up all working out in the end. So here for -3, I could do -1 times 3 or 1 times -3. So I have a couple options, right? So for my first set, I could do x and 8x, or I could do 2x and 4x, right? So I have to pick not only the second value now, but also the first value. So it's a lot more options here. And the other thing that gets tricky when you have not just x and x is that you have to watch the ordering. So for instance, over here, if I do -1 and +3, that is not the same answer as if I did +3 first and then -1 second. And the reason that it could be different is because your first terms are not the same anymore. They're not just x and x, they're different values. So the order as well could change. So in this case here, if I use the second pair now, I could have the first one be +1 and then -3, or I could have the first one be -3 and the second one +1. So within this first group, I have 4 possible values to try. And the same thing here. Well, what if it's 2x and 4x? I could use -1 and +3. Or I could use the next one, 2x +1, 4x -3, or 2x -3 first and 4x +1 second. So I'm using the combination, but again, I have to think about the ordering because now I have different numbers here. So when I multiply out, I could get different answers by switching the ordering. So it gets quite complicated quite fast here when you don't just have an x squared term in the front. So here I actually have 8 options to try. So I'm hoping I'm going to guess the right one right away. But if I don't, I'm just going to try again. So I'm going to do my first attempt. And again, if you're pretty good at multiplication and you can do some of this mental math in your head, do some of that multiplying out in your head, then that's going to really help you to hopefully narrow it down because you want to have a -10 in the middle. So you may want to think a little bit, okay, how can I get a -10? Is there any way that this seems like it's going to work? And I'm thinking here, so if I look at this first group, right, if I'm thinking about multiplying in my head, I'm thinking about that outside and the inside terms. So my inside term here would be a -8, and my outside term would be a +3. Doesn't seem like it's going to give me 10. Here, my inside term looks like it would be 24. And my outside term is -1. Again, I'm not seeing that 10 possibility. Whereas if I go over here, my inside term is 4 and my outside term would be 6. Well, 4 and 6 could be 10, right? Depending on the signs. So I'm thinking maybe this is the group I should start with. Here, I see a 12 on the inside term and a 2 on the outside term. All right. 10, 12, and 2, I could subtract and get 10, right? So for me, I'm going to start with this group because it looks like the combinations there have a likelier chance of being 10 than the other group. But that's something that just takes time. So I'm just fixing my computer for a second. So this is where that practice really comes in and really knowing your multiplication tables well comes in. So let's start with I'm just going to pick the first one to try. So let's do 2x minus 1 and 4x plus 3. So I'm going to multiply these out. 8x squared. Here I see a 6x, a minus 4x, and then a minus 3. So my inside term gives me 2x, which doesn't match. I need a negative 10. So I'm going to try something else. So let's do a second attempt. I'm going to try the next one because, again, the order changed here, so I could get different values. So here I get that 8x squared. I get minus 2x. I get plus 12x, and I get minus 3, and I get a 10x on the inside term. Now that's really close, right? I need a negative 10, not a positive 10, but I feel like I'm in the right group. So what I'm going to do is look for the same pair, but with the sign switched, and try that one instead. So my third attempt here. Okay, let's see. Let's do that last one. So I'm going to factor here. I get 8x squared plus 2x minus 12x minus 3. There's that negative 10x I'm looking for. So now I know I have the right combination, and this is the one that works. Now, when you're done, you just still want to get in the habit of just checking your factors to see if they can be broken down further. For instance, did you miss a GCF or something like that? Or if there's still squares there, they could keep being factored, but this one is complete here. Okay. All right, I'm going to do 2 more examples. And again, I know these are kind of long, but it's good to just practice with them. So I'm going to do one example now that has 2 variables in it. I'm going to look for an overall GCF first, see if I see anything here. I don't. 3, 13, 4 have nothing in common. And then some have X's and some have Y's, but they're not all the same. So I'm going to jump in with that trial and error method. And I'm going to start here. So I have 3x, and x is really the only combination, right? I'm going to try to keep my first term positive. I think it's easier. And then we'll do the signs in the second term or the last term. And then here it's a 4x squared and it's positive. So it could be y times 4y, right? Because 1 times 4 is 4. Or negative y and negative 4y. Or it could be positive 2y times positive 2y and negative 2y times negative 2y. When we are factoring our variables, we do always factor them equally. So you're never going to have one term has a square and one term doesn't. It's just going to be y. Those split equally here. And then you're just thinking about the numbers. So this one's at least a little bit nicer because I know my first group has to be 3x and x, unlike the last problem where I had a couple of different starting points. And I'm trying to get that negative 13 in the middle. So I'm looking at my different combinations to put in here. Again, don't forget order can change things to see if I can get the right one. So you can see if you can do some mental math first to see if anything seems like it's going to work. For me, if I look at those 2's and 2's, I think about putting in 2's here. So if I put in like a 2 here and a 2 here, I'm just mentally thinking, okay, well, I would get a 2 in the middle and a 6 here. Well, 2 and 6 is 8, or if I subtract them, it's 4. I don't think I'm going to get the 13. So I'm thinking I should start with the 1 and the 4 combination. So I'm going to do the plus y, and then I'm going to do the x plus 4y and see how that goes. I multiply it out, 3x squared. Here, 3 times 2 is 12, so I have 12. X times y is just xy. On the inside, I have just an xy. You can write it in alphabetical order so that your variables are consistent. And of course, there would just be a 1 there. And then here, I would do have that 4y squared. So I have a positive 13xy in the middle. So it's pretty close, but it's not quite there. Because I'm only off by a sign, I'm just going to try switching the signs and see if that works. I'm going to try this one. But don't forget too that when you have a different factor in the front, that order matters too. So you can also try not just y and 4y, but put the 4y first, right? 4y and y. So you have the ordering could be mixed up as well. So you may have to change the ordering of your factors there within the factor, right? The inside pieces. Okay. And this one looks like it's going to work here. When I combine those middle terms, I get that -13. So I kind of lucked out in this case. And well, I shouldn't say I lucked out. I did do a little bit of mental math with those 2's first. So I kind of thought to myself, I don't think this 2's are going to work. I don't see how the combination is going to happen. So I kind of narrowed down where to start. But there's still a few combinations there to try as well, right? Technically, there's still 4 because you could do 2 here and 2 here. Because again, you could also write this as 4y first as well. Okay, so you can get up in those combinations pretty quickly. Now, one last thing I want to talk about here is we do have what are called perfect square trinomials. And what ends up happening there is you have something like this for your answer. So you end up getting that same factor twice. Or it could be a subtraction one. But instead of having 2 different factors, you get the same factor twice. Now, there are formulas you can use if you're interested. So I encourage you to look at your textbook or look online if you're interested in these formulas more. But for me, I hate memorizing extra formulas if I don't have to. So sometimes it's just easier just to go through the regular process. So you can have a perfect square trinomial to start with and just use trial and error, and you gotta get the right answer. You don't have to memorize another formula. So let me just do one of those examples here. So for me, I may not recognize that it's a perfect square yet, but you probably will when you start factoring. So when you do often have a perfect square trinomial, you're going to see doubling of those factors. That's not the only thing you have to check, but it's a good sign that you probably have a perfect square trinomial. So a hint that I usually give to students, so here it's kind of nice, I only have one option, is that if you see a lot of doubles, particularly in both spots, try the doubles first. Doesn't always work because you may not always have a perfect square trinomial, but if you see the same factor here and then the same factor here, right, because they're both x's and both 3's, that's probably a good place to start. So if I try that +3 and +3, I'm still going to multiply it out to check though. I'm not going to just assume that it's going to work because it doesn't always work. Here it does, I get that match. So when we factor, you can either write it like this, or if the question wants you to write it with exponents, you can write it that way. So here's an example of a perfect square trinomial. Doesn't matter, we didn't need to use a special formula to solve it. We just used our regular technique. But again, my tip is if you start to see lots of doubles, right? Doubles in the first column and doubles in the second column, try the doubles first. Doesn't mean they're always going to work, but a lot of times they do because you may have a perfect square trinomial that you haven't recognized. But that perfect square is giving you that doubling, that kind of same factor happening twice there.